What's up, YouTube? It's your boy JOSHABRAHAM. We're back on organic chemistry. Let me pull up. It's pulled up. So 1 hour. 1 hour. That's all it gets. That's all it takes. That's all it is. Yeah. Whoa, it's so slow right now. Fuck. 15 minutes. Let's go. So last time, where was I? I know this one where there are two types of reactions directly converted into products. There's an intermediate and there's a transition state, but the transition state is almost like the intermediate, but it cannot be isolated. Okay. Carbocation, carboation, radical, carbene. Carbocation is when the carbon is in need of electrons. Carboanion is when the carbon has extra electrons in the form of lone pairs or some shit. Valence orbital, what's... Here I saw that the carbon as the outermost orbital as P is the valence orbital of carbon P orbital? Question mark? Nope. This is about which orbitals carbon uses in these intermediates. Short answer, carbon's valence orbitals are both 2s orbital, 2p orbital, not just p orbital. It's 2s plus 2p, yeah. Why p orbitals show up in your lecture in many reactive intermediates, especially carbocations and radicals when p orbital is left unhybridized, and that's why it's emphasized. Let's go each by case. Carbocation hybridization sp2. Orbitals used 3 sp2 orbitals, 3 form sigma bonds, 1 mtp orbital. I might have forgot the whole orbitals and how they work. Why is the empty orbital a p instead of an sp3? Oh, very good question. Actually, good. This is very important conception point. Okay. I don't want to read that. What does sp2 hybridization actually mean? Carbon has 1s orbital, 3p orbitals. When it becomes sp2 hybridized, Carbon has 1s orbital, 3p orbitals. When it becomes sp2 hybridized, 1s 2p orbitals mix gives 3 sp2 orbitals. 1p orbital is left unused. That's the key. sp2 means only 2p orbitals are used. 1p orbital remains unhybridized. Oh, then here it's sp3. Okay. sp2s overlap. P orbital contains an unpaired electron. So, let me see. Let me bring out my OG. Yo, my phone just connected to WhatsApp or? Reactivity of organic compounds. So I'll name this note organic chemistry reaction mechanism. Mechanism. Reaction A plus B. Oh, should I share? Should I do the writing? Yep. It is seeable, right? It's visible. A plus B gives C plus D. Normal reaction. A plus B gives X, which converts to C plus D. Intermediate. Intermediate product or intermediate that can be isolated, at least detected. A plus B. I don't know. Like the notes hashtag. It's what's the name? It's not intermediate. It was. I just read it. I just read it. Intermediate. Transition. Okay. Okay. It's basically highly reactive, short-living, highly reactive C plus D, short-living, intermediate that cannot be isolated. Okay. I feel like the keyboard is annoying at this point. Fast transition stage is intermediate. Now we're moving to different types of carbocation. Intermediates. Common carbo-based intermediates. Yo, somebody just used the chat. Nishant. Yo, what's up? I believe there was a call, right? The phone was being used. I was not able to attend the call. How you doing? Oh man, after tomorrow, I gotta head straight to work. Intermediates, common carbon-based intermediates. Yeah. How you doing, brother? Carbocation. Bond formed by sp2s overlap. sp2s. Wait, there's 3 hydrogen? Metal cation. Metal anion. Oh, 4. Okay. Okay, I'm just gonna write it. Carbocation. R3C plus. Carbocation R3C plus. What is that though? Yeah, it's let me draw this. H C H H F sp2s overlap. What? If there's only... Okay, 3 sp3, sp2. 1 s and 2 p orbitals form 3 sp3, sp2 orbitals. Fuck, I hate the hydrogen. That's obstructing. Oh, come on. Day പിന്നെ എന്തുണ്ട് വിശേഷം? What can I say, man? പ്രത്യേകിച്ചൊന്നുമില്ല. നാളെ വർക്കുണ്ട് മയിര്. Yeah. So before that, I gotta submit my assignment. I have one assignment to submit. What else? I got exams coming up, and next Wednesday I'll be continuing Sleeping Dogs at 8:30 p.m. Let's go. That's cool. That is cool. Not gonna lie. MTP orbitals. I recently saw the YouTube video from your cousin. What was the name? I forgot his fuck. Hirtik Haksalal. But on his recent video, I did not hear your voice. There's no money? There's no Minecraft with no money, bro. What are you talking, bro? We need money back. Is it not visible? The tablet is not visible. And whoa, I hate the laptop being seen. What can I do? Was kann ich tun? Was kann ich machen, dass ich die Laptop get rid of the laptop scene? It's a coffee. It's a pure coffee. It's been a long time since I had tea. Let me big it up, big it up. Oh, okay, there we go. That's pretty big, but it's now the screen is... Wait, I got one more idea. There we go. There we go. At this age, at this point, it's hard to live without the coffee. It's starting to look like an addiction. Carbocation, yeah, with MTP orbitals and 3 sp2 orbitals. Now what's the next one? Carbanion. That's C minus, right? Right, yeah. So let me just draw this. 2 dots, right? Now one lone pair electron are in the sp3 orbital. Bond formed by sp3s orbital. What? Say what? Okay. Wait. Could you explain why Carbanion now have Carbanion now have what? 3. Oh wait, 4. 4 sp3 with 1 not formed included in the bond, rather as a lone pair. There. Could you also explain why the carbocation has sp2 orbital bonds Good. This is the exact comparison you need to understand deeply. Let's build it step by step. Start from the neutral carbon. Carbon has 4 valence electrons, 4 bonds. Octet equals... Did I complete the coffee? No. Octet equals 8 electrons, yeah. It forms 4 pi bonds, sp3 hybridization. Carbon now has 1 extra electron, negative charge. So total around the carbon, 3 bonds, 6 electron, 1 lone pair, 2 electrons. Why sp3? Carbon needs 4 orbitals to hold 3 sigma bonds, 1 lone pair. It mixes 1s and 3p orbitals. I forgot to set the timer. I remember setting a timer. 22 minutes. 8 minutes. Why carbanion is sp3? 1s and 3p. Then 3 sp3 orbitals, 4 bonds, 1 sp3 orbitals holds a lone pair. Why is it now 1s and 3p and here it's 1s and 2p? Carbocation. Carbon lost 1 electron, positive charge, total around the carbon 3 bonds equals 6 electron, incomplete octet. Why not sp3? To be sp3 you need 4 electron groups, but carbocation has only 3 bonds. No lone pair. So 3 regions of electron density, so it uses sp2. Leaves 1 p orbital unused and empty. So empty p orbital, filled p orbital, but no bonds. Okay. So now it's gonna look like C minus well, the minus should be the whole thing, right? Okay. A normal H, a fucking H on the top, a H on the bottom, and a big ass lone pair. sp3 orbital containing lone pair with lone pair. sp3s bonds, carboanion. Now it's time for radical. R3C minus? That's just a... It's not even a full minus, what? I did not exactly get the symbol used for radical. Was that a dot next to carbon? Yes, exactly a dot. Okay. Okay, whatever you say, GPT. Whatever you say. So now it's again SP2S. Why is it now SP2? Could you explain again why the radical is again having fuck LinkedIn SP2 orbital, even though it has one electron, right? It could have been in the SP3. What determines hybridization? Hybridization depends on the number of electron groups, regions of electron density, bonds per lone pair. For radical, what does the carbon have? 3 bonds, 1 unpaired electron. Is unpaired electron the same as a lone pair? No. Okay. So how many electron groups? 3 bonds, 3 groups. Single electron does not form a full region like a lone pair. So we treat it as a 3 electron groups. Therefore sp2 hybridization. This is where is the unpaired electron? It sits in the unhybridized p orbital, just like the empty p orbital in the carbocation. I guess. H. Fuck. sp2s bond, unpaired electron in unhybridized p orbital, or just p orbital. Okay. Why? I'm guessing carbene is gonna be is it gonna be for carbene? I feel like it's gonna have sp3 hybridized orbitals involving both bond and lone pairs. Or is it gonna be sp orbitals? Two bonds, two extra only two extra electrons? Four. Should be four, right? Fuck, it's a sp2? What? I gotta see the carbene structure. Carbene intermediate. So p orbital half full, sp2 hybridized, sp2 orbital half full. So it has an sp2 orbital. 8 minutes. Guess what, gang? Push-ups. Ow. Oh fuck, my legs ain't fucking working. $15. So this is how carbene looks. Oh, there's a triplet carbene and a singlet carbene. Oh, okay. Which carbene are we talking about here? It's not mentioned, okay. It is not mentioned. Two bonds, two extra electrons. Most type first. Structure, two bonds, one lone pair. Count electron groups. Two bonds equals two groups. One lone pair equals one group. Total 3 electron groups. Hybridization, sp2. 3 sp2 orbitals used for bonds. Holds the lone pair. Remaining p orbital is empty. Triplet carbene. Structure, two bonds, two unpaired electrons not paired. Count electron groups. Two bonds equal two groups. Two single electrons behave separately. This leads to sp hybridization. Ah, okay, the triplet singlet carbene. Okay, so right now I'm learning this one, where it's a full sp2 orbital is full and p orbital is free. Okay, two bonds and one lone pair of electrons together. Okay, what was I writing here? Why both the carbocation and radical has sp2 hybridization, while the carbanion has sp3. It's because of the number of electrons involved. Carbocation and radical six electrons total in bonds, 2 per bond. Two S plus S plus 3p, right? No, it's 2p. 2p. 2 plus, 2e minus plus 4e minus equals sp2 orbitals. While in the case of carbanion, whereas in the case of carbanion, 8 electrons total, 3 bonds, 1 LP, S plus 2, 3p, 2e minus, 6e minus, sp3 orbital. Okay, now it's time for carbene, right? R2C dot dot. Carbene, 2 types. Singlet. We start with singlet. Singlet. Triplet. Carbene. Two bonds, one lone pair. Two bonds, one LP. So it's the double bond. Radical, we got one on the p orbital, empty p orbital, carbocation. We got one empty p orbital, carboanion. We got sp3 orbital filled, carboanion. Wait, these are same carbanion? Why? Oh, it's either sp2 3 sp2 orbitals filled with the empty p orbital filled, the p orbital filled, or it's 4 sp3 orbitals filled. Why? What? You know what? Right now, let me write what this means. Singlet carbon. We got a carbon. We got a hydrogen at top. And we got a hydrogen at the bottom. We got, what's this? I don't know. That's the empty p orbital. And that's the empty sp orbital. Empty p orbital, a lone pair, LP on the sp2 orbital, right? Oh wait, in the case of triplet, oh, that was what, okay. I just picked my nose, but let me throw this away. Okay, let me see. The other one would be, no, let me first write this. So one LP lone pair, oh, is there more to write here? No, p orbital is empty. Six electrons in total. S plus 2p. 3 sp2 orbitals, 2 bonds, 1 lone pair. p orbital empty. Triplet carbene has also 2 bonds and 2 electrons. 2 unpaired electrons. 15 minutes. I guess push-ups. Push-ups. Fifteen minutes. Empty p orbital, not empty. Half-filled p orbital and half-filled Why is it like this though? sp2s in sp2, 1 UPE minus in p orbital. Okay. 6 electrons in total with two p 3 sp2 2 bonds, 1 unpaired electron, in p orbital. Okay, I get how carbene and how the electron pairs or unpaired electrons are split across the atom, but could you explain even why the triplet carbene exists? I feel like singlet is more stable compared to triplet. Good, this is a deeper question, not just memorization. You're right to think paired electrons should be more stable than unpaired. But in carbene, it's not always that simple. Let's unpack it. What are we comparing? Singlet carbene, two electrons paired in one orbital, one lone pair MTP orbital. Two electrons paired in one orbital, one lone pair MTP orbital. Triplet carbene, yeah. Two half-filled p orbital. What? Two half-filled p orbital? I thought it was two electrons unpaired in two different orbitals. sp, two half-filled p orbitals. What? What do you even mean? I thought the two unpaired electron was across one sp2 orbital and p, each having a single unpaired electron. Types of reaction in organic chemistry. A lot of different reactions known in organic chemistry. Most of them are based on one of the following three types: substitution, addition, elimination. Correct picture of triplet carbene. Carbon forms two pi bonds, two remaining p orbitals. Each contains one unpaired electron. That's why it's called triplet. Parallel spins in separate orbitals. Why not sp2? If it were sp2, you would have this is higher energy and less favorable. Why sp is better for triplet? Because it gives two separate p orbital. Compare cleanly. Your idea incorrect for triplet. Electrons in different types of orbitals, uneven, higher energy. Actual triplet. sp hybridized. Two p orbitals each. What? That's not what it's shown here. Nope. I just searched in Google and I got a picture, or let's say reference on the difference between singlet carbene. The main difference being fully filled or lone pair and 1 UP each sp2 and p orbital. Good that you checked, but this is where diagrams online can be misleading, but you don't interpret them correctly. What you saw, you're describing something like singlet, paired electron in one orbital, often drawn in p orbital. No. This picture exists, but it's a simplified alternative representation, not the most accurate way to think about hybridization. Electrons prefer separate orbitals of similar energy to minimize repulsion. Proper understanding of the triplet carbene most accurate model. Carbon is closer to sp hybridization. 2 unpaired electron and 2 separate p orbitals. This is the lowest energy, most accepted description. Why some diagrams show sp2p? Those diagrams are simplified in orbital pictures, sometimes mixed bonding. The fuck you talking? It's not even not one. Yeah. Singlet. It kind of makes sense. Triplet carbene structure. I'm getting too invested on this. Not even a single one showing opposite p orbitals being filled. It kind of makes sense for triplet having each UP in opposite p orbital to avoid or to maintain the least repulsion. But I don't even see a single picture on this. I don't see a single picture on this where the triplet is having 1 UP each on opposite p orbital. Bro, I get what you mean. Okay. Oh, px and y. I thought it was px and like px minus. I don't know. I feel like this is wrong. GPT is just answering wrong. Carbene is a molecule containing a neutral carbon atom. I want the structure. 15 minutes. I guess organic chemistry is about to end. The two unpaired electrons typically form from reaction that breaks two sigma bonds, have elimination, and do not rehybridize the carbene atom. Singlet carbons have single lone pair, typically form from diazo decomposition and adopt an sp2 orbital structure, the lone pair. Okay. Bond angles are, okay, I don't care about the bond angles. Most carbenes are non-linear triplet ground state. For simple hydrocarbons, triplet carbenes are usually only 8 kilocalorie more stable than singlet. Triplet is more stable than singlet. Diradicals, often ground state for simple carbenes. Energy difference triplet. Important correction, triplet carbenes do not hybridize. This is misleading. What? You are telling me Wikipedia is misleading? Triplet carbenes do not have defined orbital arrangement. Most common model is sp hybridized, not no hybridization change. Singlet always sp2, triplet no rehybridization. Too simplified. Singlet sp2 lone pair fits. Triplet sp minimizes electron repulsion by using two p orbitals. You know what? I got a question that I need to ask my professor. I got a question that I can. Oh, it's on the new page. Question to ask Professor Carbene. Singlet. Triplet. So singlet, we're gonna have lone pairs. One LP on sp2. sp2s. Okay. Now triplet. I'm having doubts. One UPE minus in p orbital and one UPE minus in sp2 orbital, or wait, so you are saying that sp for triplet carbene, it's sp3, no, sp instead that is involved in bonding and unpaired electron. So the bond between hydrogen to unpaired p orbitals. Wait, so the CH bond in triplet is sp, and I could sue ChatGPT for this part. Maybe you are saying false information. sp wait, so I mean so the CH bond in carbene is sp, and the empty and one empty sp orbital remains with one UP electron two p orbitals remain unhybridized. Oh, only two sp2. Okay, sp2 s bond. Okay, and we got two p orbitals. Two unhybridized p orbitals. This were unpaired electrons. One electron with each having one UP electron. Okay, I think that's good enough. 15 push-ups, and I'm gonna stop this stream and start with what's it called? Thermodynamics assignment. This one, baby. This one, baby. This one, ads, just ads. I gotta get that part correct. Push-ups. Fuck. Forgot. Okay, that's done. Peace out, YouTube. I'm gonna be back with something else.